All right, let's dive into something that sounds kind of formal, set operations. But I promise you, it's actually the secret language behind pretty much all your favorite apps and the code you're going to be writing. Seriously, by the end of this, you'll start seeing it absolutely everywhere. Let's get to it.
So as a tech student, you're constantly making choices, right? Are you on Team Python or Team Java? Do you build stuff for iOS or for Android? Well, every single one of these choices puts you into a specific group, a set, if you will.
And it's not just about what programming language you prefer. Think about your music playlists, the group chats you're in, even your friends on different social media platforms. Believe it or not, your whole digital world is just neatly organized into these little collections, these sets. Today, we're going to learn the secret rules for how all these sets talk to each other.
Okay, first up, the union. Let's pretend your university has two big tech clubs, right? The Python Club and the Java Club. Now, what if you wanted to throw a huge tech social and invite everybody from both clubs? Well, that's exactly where the union comes into play.
So, what is a union, really? The key word you got to remember is or. As you can see right here, the union of two sets, let's call them A and B, is everything that's in set A, or in set B, or in both of them. Basically, if you're in either group, you're on the list. You get an invitation. So, going back to our club story, the union is just the master guest list for our party. We grab the list of every single student from the Python Club, we add every single student from the Java Club, and boom, it's one giant party where absolutely everyone is invited. Nobody gets left behind.
Now let's look at how this actually works with some numbers. Let's say set A, the Python Club, has student IDs 10, 11, 12, and 13. And set B, the Java Club, has IDs 13, 14, and 15. The union includes everybody, 10, 11, 12, 13, 14, and 15. But wait, did you notice student number 13? They're in both clubs, but on our final list, they only show up once. That's a key rule with sets. They don't do duplicates.
Okay, so a union is all about bringing everyone together. But what if we're not planning a party? What if we want to find those super ambitious students, the ones who are so into coding they joined both clubs? For that, we need something totally different, the intersection.
For an intersection, the new magic word is and. It's way more exclusive. As this slide shows, it's the set of elements that are in set A and also in set B. You have to be a member of both clubs to make the cut.
So, back to our clubs. The intersection is how we find those overachievers, the students who are learning both Python and Java. They're the ones who exist in that little overlapping part between the two groups. They're kind of the bridge between both worlds. And let's look at the numbers again. If set A is our Python club with members 11, 12, 13, and set B is our Java club with 13, 14, 15, what's the one ID they both share? You got it, it's 13. So the intersection is just a new set with that one single number. Simple, right? Very, very specific. All right, so we've combined groups with union and we've found the overlap with intersection. But what about the exact opposite? What if we want to find the loyalists, the students who are dedicated to only one club? This is where our last operation comes in handy, the set difference.
The set difference, which we write as A minus B, is pretty much exactly what it sounds like. We start with everything inside of set A, and then we just remove or subtract anything that's also hanging out in set B. What you're left with are the elements that are only in A and nowhere else.
Now, listen up, because this is probably the most important part. The order here matters a lot. If we do Python Club minus Java Club, we find the Python-only specialists, the students who live and breathe Python but are not in the Java Club. But if we flip it and do Java Club minus Python Club, we find the Java-only purists. See? Two totally different groups of people. And the numbers make it crystal clear. Using our same sets, for A minus B, we start with the Python Club and kick out the one member who's also in the Java Club. That's number 13. So we're left with the Python loyalists, 10, 11, 12. Now for B minus A, we start with the Java Club and take out that same overlapping member, 13, and we're left with the Java specialists, 14, 15. See? Completely different outcomes. So if you remember one thing about set difference, let it be this. A minus B is not equal to B minus A. Unlike when you're just adding numbers, with set difference, the order you do the operation in completely changes the entire results. Okay, so clubs and student IDs are a fun way to get the hang of this, but let's get real. Why does any of this actually matter for your future career in IT?
Let's connect the dots from this simple theory to the actual code you'll be writing every single day.
Trust me, this isn't just some abstract math concept. It's the engine behind so much of what you'll do. When you write a database query to find all the users who bought product A or product B, well, that's a union. When you're trying to filter a marketing list to find users who are on your newsletter but not your free trial list, that's a step difference. And what about managing permissions to find a user who is an admin and in the finance department? Yep, classic intersection. This is your fundamental toolkit for working with data.
So the big idea here is that these operations are literally everywhere, hiding in plain sight, from your phone's contact list to complex security systems. So the next time you see a movie recommendation or get a super specific ad, ask yourself, what kind of set operation is working behind the scenes here? It's a fun little game to play. Thanks for tuning in.